Hello viewers, my name remains Ajiboye Oladam Jacob and I welcome you to the Global Tutor YouTube classroom. Today we want to look at the subject chemistry. And I want to look at the topic naming of organic compound. Naming of organic compound. Now, for you to name an organic compound effectively, I will follow these three principles that I've been using for students over the years. Number one, you need to know the prefix that you are going to use. Number two, you need to know the suffix that you are going to use. And number three, you need to know some set of rules which are called general rules. You need to know prefix, you need to know suffix, and you need to know some general rules. Now, let's start with the first one, prefix. Now, the prefix you use to name an organic compound is determined by the number of carbon that is present in the compound. What am I saying? It means if you see an organic compound, the first thing you look for is how many carbon atoms are there. So if you know the number of carbon atoms that are there, then part of the problem is solved, because by then you know the prefix you are going to use. Let me draw a table and show you the number of carbon for carbon 1 to 10 and the prefix we are going to use. Let's have number of carbon and let's have prefix. Now, if the number of carbon is 1, you use the prefix met. If the number of carbon is 2, you use the prefix ect. If the number of carbon is 3, you use the prefix pro. If the number of carbon is 4, you use the prefix put. If the number of carbon is 5, you use the prefix pent. If the number of carbon is 6, you use the prefix x. If the number of carbon is 7, you use the prefix x. If the number of carbon is 8, you use the prefix ot. If the number of carbon is 9, you use the prefix non. And if the number of carbon is 10, you use the prefix tec. Now, what I'm trying to point out is, if you look at an organic compound and the number of carbon you have there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Either of these are the various prefixes that you're going to use for them. For instance, if you have a compound and the number of carbon there is 4, it means the prefix you're going to use is going to be but. If you have another compound and the number of carbon there is 7, it means the prefix you're going to use will be et. That is what we call prefix in naming of organic compound. Let's consider the second one, suffix. Let's consider the second one, suffix. Suffix. Now, the suffix is from the root or what we call the family name. The suffix is usually from the root or what we call the family name. Every organic compound belongs to an homologous series. Every organic compound belongs to an homologous series. Now, one of the peculiarities of homologous series is that they have the same method of naming. One of the peculiarities, there are several peculiarities of homologous series, but in this class we are talking about naming of organic compound. One of the peculiarities is that they have the same method of naming. Now, what is that same method of naming that the peculiarity is talking about? Is because they have the same suffix, the same ending. I'm going to draw a table. I will show you the homologous series and the suffix you use for each of the homologous series. Let's say this is the table, homologous series. Let's say this is general molecular formula for the compound. Let's say this is the functional group so that when you see the functional group, you can identify the homologous series to which it belongs. Then let's say this is the suffix. Now, the first homologous series to be considered is called alkane. Alkane. The general molecular formula of alkane is CnH2n plus 2. And the functional group of an alkane is single bond. And the suffix we use is ane. Now, what does this mean? What this means is that if you see a compound, and that compound belongs to the alkane homologous series, if you look at the compound and it satisfies the formula CnH2n plus 2, and it has a functional group of single bond, then that compound is an alkane, and you name it by putting ane plus the suffix you have discovered. Let's assume we have CH4. Structurally, you're going to have something like this. So this is an alkane because it obeys this formula CnH2n plus 2, and the functional group is single bond. So remember I said when the number of carbon is 1, you use met. Now we have the suffix for the alkane homologous ane. So it means this compound is called methane. If you consider this one C3H8. Now how do we draw that? We have C3H. So this is H, 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 H. So this is C3H8. Now 1, 2, 3. I said 3 is what? Pro. Now this family is what? Alkane. So this becomes propane. Now if you consider, let's say 7. 1, 2, 3, 4, 5, 6. Then you have H. You have H. You have H. Now this will be 1, 2, 3, 4, 5, 6. 6 is what? X. Then what is the family name? ENE. So this becomes hexane. So homologous series alkane. The general molecular formula is CnH2n plus 2, and you name them by putting ane to the prefix you have determined. So for this one there are 6 carbon. So you have X. Then you have plus A, which is the suffix. For this one we have 3 carbon. This is pro. Then you add E to what? The family name ane. Then for this one, it is 1 carbon. So you have met. Then you add it to what? ane. That is the what? The alkane homologous. Now, if we move to the second homologous series, we call it alkene. Alkene has a general molecular formula CnH2n. And the functional group is double bond. And you name them by putting ene as the suffix. You name them by putting ene as the suffix. Now, the first member of an alkene homologous is the one with 2 number of carbon, because there is a double bond existing between 2 carbon atoms. So the first member of an alkene do not have a member with 1 carbon, but rather the first member has 2 carbon, that is C2H4. So if you want to draw it, you have C double bond C, then you have H, 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 H. So you have H here, you have H here, you have H here, you have H here. Now, 2 number of carbon is what? 8. Then you put the family ene, that's 18. If you want to draw the one, let's say it has 4 carbon, C4, H8. So you have C1, 2, 3, 4. Let's say the double bond is here. So you have 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So this is what the number 3 member of the what? The alkene homologous. So how do we name it? 1, 2, 3, 4. 4 is what? Boots. Then what is the family name? Ene. So you have butene. As we go on, when we get to the general rule, I'll give you a rule where you can consider the position of the functional group, but we are not there yet. So just know that we are trying to combine prefix and suffix. So you have 1, 2, 3, 4 boots. Then the family name is Ene. That is for the alkene. So you have butene. That is what? Alkene homologous. The number 3 homologous series we will consider is the homologous series we call alkene. Alkene. Alkene has a general formula CnH2n minus 2. And the functional group is 1, 2, 3, a triple covalent bond. You name them by putting Yne as the what? As the suffix. Now, like the alkene also do not have member with 1 carbon. The first member also have 2 carbon. So you have C2H2. So you have C triple bond C. Then you have H. Then you have H. This is the first member of the alkyne homologous. Remember we said 2 number of carbon is et. Then you put the root name, which is the suffix, Yne. So this becomes ethane. That is 2 carbon triple bond. Then you have HH. That is the first member of the alkyne homologous. Let's assume we have the one with 3. So you have carbon, 1, 2, 3. Carbon, you have carbon, you have this. So this 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Each bond surrounding a carbon atom must be 4. So 1, 2, 3, that is pro. Then what's the family name? Yne. So propane. That is the what? The alkene homologous. So what is the pointer to look for? You look for the functional group and you look for the what? General molecular formula. So when you look at the functional group and the general molecular formula, you'll be able to determine the homologous series to which they belong. When you know the homologous series, then you will know the suffix. So we have looked at the alkane, the alkene, and the alkyne. Now before I go on, I'd like to look at a group. It is not an homologous series, but it is very important for our naming. We call them the what? The alkyl groups. Now, what are the alkyl group, or what does alkyl group stand for? An alkyl group is an alkane that has lost 1 hydrogen atom. So you have CnH2n plus 1. You know alkane we said CnH2n plus 2. But now we have CnH2n plus 1. We call them the alkyl group. They have lost 1 hydrogen atom. So you have, let's say for instance, you have CH3, you have C2H5, you have C3H7. Now, how do we name this one? We name this one by putting YL with the what? The prefix. We put YL with the prefix. Now, the interesting part of the alkyl group is that we use them in describing the general molecular formula of other homologous series. And we normally use the symbol R. So anytime you see the symbol R, it denotes an alkyl group. So this one now, you can name it as methyl. Met, 1 carbon. Then this one, et, 2 carbon. Then til. Then this one, 3 carbon. That becomes propyl, 3 carbon. So you name an alkyl group by putting YL, and you symbolize an alkyl group with R. So if I go to the next homologous series, I have alkanol. Now, for alkanol now, I can say the general molecular formula is ROH. What is this alkyl group? What is our group? CnH2n plus 1 bonding with what? With OH. So what is the functional group? The functional group is OH. How do we name alkanol? You put OL with the name OL. So if you come here now, you want to see how to name alkanol. You have CH3OH, meaning you have R is what? CH3, then bonding with OH. So you have CH, H, then you have OH. So this becomes met, one carbon, tanol. You have C2H5OH. So you have C123, C123, then you have OH. These are H. So this is 1, 2. This becomes ethanol. You have C1, 2, 3, let's say 4. You have OH. 1, 2, 3, 4. 4 is what? Good. So you have butanol. So what we have done in today's class is that we have seen prefix. And prefix is determined by the number of carbon. I gave you a table for carbon 1 to 10. Then we have looked at suffix. And I said suffix is determined by the homologous series to which a compound belongs. And in today's class, we have been able to look at the alkane homologous, the alkene homologous, the alkyne homologous, and the alkanol homologous. I will pick it up from here in the next class. But before I go, please like our video, subscribe to our channel, and share our videos. Thank you.